Hello and welcome to another JFrog tutorial. The focus for this topic is planning for topology on your geographically dispersed Artifactory instances. Today's modern DevOps are more commonly dispersed across data centers and clouds over geographic locations. A strategic multi-site topology between locations can alleviate or completely remove geolocation barriers of the past and can expedite development or deployment of software solutions. In this tutorial, we'll present an overview of replication and multi-site topologies, methods for replication, and two common topology shapes, namely star and mesh. Replication in Artifactory is very flexible and can be shaped into what your organization needs best. Multi-site topology in Artifactory defines how artifacts are copied from one instance to another. By leveraging replication capabilities, you can define repositories to be synchronized across Artifactory instances, leveraging change or scheduled events, and setting the control for replication, whether it is by pushing or pulling the artifacts from the source repository to its targets. Without replication, you can leverage remote repositories that act as caching proxies and pull artifacts on demand across a network between two distant locations. Limited by the speed of that network, the pull can take a long time and slow down the network for other important transfers. On the other hand, if the artifacts are replicated in locations where they are needed, per event or on schedule, then files are already local and ready for use when they are needed. For example, let's say you have a development team in Bangalore and a team in Boston that both share artifacts as part of the continuous development process. If the team in Bangalore has to pull artifacts on demand, the request ends up taking a long time to process over the network. This slows the build process. And when a new dependency is introduced in the source but is not yet available in the second site, the build will break. However, if you rush a push replication, the artifacts in Boston are replicated to a repository in Bangalore, where it can be pulled at LAN speed. Let's take a look at some of the methods for replication. Replication can be initiated from either the source with the push or with the target as a pull. The originator also dictates the timed availability of the artifacts to the target Artifactory service. What's the difference between a push and a pull, and why does it matter? A push replication is triggered by the source Artifactory service to transfer the changed artifacts to the target service. With a pull replication, the target Artifactory service triggers the transfer, taking all the changed artifacts. In our earlier example with our teams in Boston and Bangalore, the artifacts at the source in Boston were replicated to the target in Bangalore, where it was ready to be pulled when the team by Bangalore when it was needed. You can set the replication to be automatically initiated on a scheduled date and time pattern, or be triggered by every artifact change event, such as a build update on the source repository. An event-based push occurs immediately and at network speed, triggered by each action on an artifact, such as create, copy, move, and delete. Event-based push replication is fast, asynchronous, and minimizes the time repositories are not synced. One of the downsides, however, is that you can't throttle the network during a push. To overcome any network issues or downtime, Artifactory triggers a scheduled replication as a fallback to address any missed change events. Pull replication can also be triggered by the scheduled date and time. But even more interesting is the event-based pull replication. An event-based pull immediately transfers the metadata for the artifact for every change so that it's visible right away, even before the binary data has completely transferred. The binary itself will be transferred on demand upon the first client request. This transfer of metadata mitigates the risk of breaking builds on the target site when new dependencies are introduced. The new dependencies are immediately visible but not actually transferred until needed. Because of this constant replication, and in order to maintain consistency, you would never want to deploy builds to the target repository. Local repositories used for the replication target should be read-only for all clients. Deciding whether you need to push or pull data depends on the workload at each instance, the shape of your network, and the nature of your build consistency across sites. You might shape your topology in a number of different ways, but the two ways we describe here, which are the most common ones, are the star topology and mesh topology. The easiest topology to manage is a star topology, which includes a few remote sites around a central hub. For example, let's say you have Amsterdam at the center of your development where you can produce artifacts. Remote sites in Bangkok, Cape Town, and Chicago are where you conduct tests or deploy your artifacts. These remote sites consume artifacts that are produced in Amsterdam. Both push and pull replication can be used in a star topology, each with its own set of advantages. But another topology you could set up is a mesh topology. A mesh is more suited to development that is equally distributed among multiple sites, where each site can consume and produce artifacts to be used by other sites. Let's take a look at our distributed data center organized as a mesh rather than a star. In this example, Amsterdam could push changes to Bangkok while Bangkok is pushing changes to Amsterdam. Meanwhile, local builds push artifacts to the local, write-enabled repository, while artifact consumption is done using the aggregated repositories of both local and remote sites. With a mesh topology, you can extend to any number of sites. In fact, let's add Cape Town and Chicago to the mesh. Something that can arise from a mesh topology is bilateral replication, which can get caught in an infinite loop. Artifactory replication is one way to avoid this, but you can use a virtual repository to simulate a bidirectional replication. A good way to set this up is to have each site manage a virtual repository that includes a local and remote repository. Each site can only write to its own local repository, while the remote repository is populated by using a replication from the local repository on the other site. So the remote repository in Bangkok pulls from the local repository in Amsterdam, and Amsterdam does the reverse of that. In a mesh topology, the repositories used for replication can quickly become unorganized without a consistent naming convention. We recommend a 4-part structure that includes the team or product, technology, maturity, and locator in that order. For example, the team Swamp Dev, using Maven for a staged build in Bangkok, would be labeled swampdev-maven-stage-Bangkok, as shown here. We recommend reading the naming convention white paper for further information on this recommendation. Planning for multi-site topology keeps your development pipeline running. A few considerations regarding your network and distribution model will help you decide how to optimize topology in Artifactory. Let's start with your Artifactory license. An enterprise license enables multi-push replication, which pushes multiple sites at once, as well as support for event-based pull replication. Pro license is restricted to support push replication to a single site. Make sure you have the right license to support your topology needs. The next thing to consider is your network, which has a topology of its own. Some networks limit your unilateral communication, such as when a NAT firewall is being used. Anything from inside the firewall can reach anything outside the firewall, but communication is limited coming in. Among other considerations are whether to push or pull the replication, whether to schedule a push or initiate it based on an event, and how to shape your topology. We've shared some ideas on the form and function of multi-site topology, but this is a diverse topic that presents a lot of options for your replication setup. In this tutorial, we gave you an overview of topology, provided information replication methods, we described the structure of star and mesh topology, and we listed some considerations for planning your topology. Remember to look for more information in our online user manual and other resources you can access from the JFrog website. Have fun building your multi-site topology strategy, and thanks for learning with JFrog Academy.